So total 20 marks. So this topic is for 20 marks for your second quiz. Okay. So that indicates how it is important. Okay. So see here. So 1 marks problem, 1 question is there. So 2 marks problem, 2 questions are there. So 3 marks questions, that is also 2 questions are there. And 4 marks question is 1 and 5 marks question is 1. So totally, so this is for 20 marks. Here 5 marks, 4 marks, so 9 plus 6 and 4 marks. Okay. So before we going to discuss about continuity, some basic concepts are very important to better understand the definition of continuity and differentiability. So what are those? So one is constant. Okay. So variable, limits, dependent and independent variables. So before that, this is dependent variable, independent variable, and then limits. So these are very important concepts. So you know in the first piece also. So what is a constant? So constant is nothing but a quantity which remains same during the set of mathematical operations. That is constant, a quantity which remains same during set of mathematical operation. So that is nothing but constant. So see once again, constant is a quantity which remains same during set of mathematical operation. So for example, so you know that area of circle. So area of circle, that is A is equal to pi r square. So here the value of pi, which remains same. So during any set of mathematical operations, sometimes we may take r is equal to 1, r is equal to 2, r is equal to 3, whatever the value, but the value of pi which remains same. Okay, so that is called constant, and 2 is also a constant. Okay, so variable. So variable is equal to a quantity which takes different values during mathematical operation. So such a quantity is known as variable. So say a quantity which takes different values. Okay. So different values during mathematical operations. So they are called variable. So here, so in the example, so pi is constant. Okay. So r is variable. So why? Because r is variable. So a is also variable. Because see, so during set of mathematical operations, the value of r is take different values. So that is called variable. Okay. So and one more thing is dependent and independent variables. So again, so variables are classified into dependent and independent variables. So see here, see the same example. Okay, or f of x is equal to y. Is any function. So in this function, the value of the x is independent variable. So that means the value x takes a different values. So x takes a different values. So but the value of y is depending upon value of x. So therefore here x is independent variable and y is dependent variable. Okay. So independent and different variable. Okay. In the function, so dependent variable. Why is dependent variable? So why? Because the value of x is independent. So it may take any real values. The function f is valid what they takes any real values, that means it is independent. So the value of y is purely depending upon the value of x. So therefore that is a dependent variable. So okay. So in the same example, so r is independent variable and a is dependent variable. So because the value of a is depending upon the value of r, so therefore it is a dependent variable. Okay. So limits. So already know that in the first we see also the definition of limit. Just I will recall the limits. Okay. The function f of x is said to tend to limit L as x tends to a, as x tends to a if numerical difference between f of x and L becomes smaller and smaller whenever numerical difference between so x and a is smaller and smaller. So okay, so this is the definition of the limit. The function f of x is said to tend to limit L as x tends to a if numerical difference between f of x and L becomes smaller and smaller. So whenever the numerical difference between x and a is smaller and smaller. So already you know all these things in first QC. Okay. So these are the basic concepts which are essential to understand the definition of continuity and differentiability. Okay. So write down this. So next is left hand limit and right hand limit. Okay. So left hand limit, left hand LHM. So left hand limit and right hand limit. Okay. So this is also in the first QC. So limit f of x as x tends to a minus. So x tends to a minus is called left hand limit, and right hand limit is limit f of x as x tends to a plus. condition. Okay, in higher studies also the continuity and differentiability is very important and very weightage topic. Okay, so therefore don't neglect this. Okay, so continuity. Okay, continuity. So generally the function f of x is said to be continuous. So any function, suppose is said to be continuous. Generally, I am talking about generally. So suppose this is a function. So f of x. Observe here in this function. So generally we observe that in this function there is no break, as there is no jumps. Okay. So this is continuous from the point so A to B. Suppose it is B and this is point A. Okay. So in this curve there is no break or there is no jumps at all. So therefore, so this is called a function, continuous function from the given interval. Okay. Suppose I take one more graph. So one more graph. Suppose this is the function. So here CA. So there is a gap. Okay. Suppose here at the point A, CA, it is continuous everywhere, but it is discontinuous at x is equal to A. Okay. So see in this point the curve, there is a break or there is a jump. So it is called discontinuous at x is equal to A. So therefore, to verify whether the function is continuous or discontinuous, so you must know the definition. A function f of x is said to be continuous at x is equal to A. A function f of x, a function f of x is said to be continuous at x is equal to A. So if limit f of x as x tends to A plus or A minus, which is equal to limit f of x as x tends to A plus, which is equal to f of A. Okay, then the given function is said to be a continuous functions. Okay, that means left hand limit is equal to right hand limit is equal to f of A. F of A is nothing but value of the function at x is equal to A. So then the function f of x is said to be continuous at x is equal to A. Okay, so write down. So f of x is continuous. So here f of x is continuous. F of x is continuous. So here f of x is discontinuous. At x is equal to A. Okay, at x is equal to A. So write down the definition and graph also. Okay. So or this definition can also be defined or. Okay. A function f of x is said to be continuous. At x is equal to A. If first condition, if f of x is defined at x is equal to A. Okay, and second one, f of x is exists at x is equal to A, and f of x, limit of f of x. Second one is this one, third one. So limit of f of x as x tends to a, which is equal to limit of f of x as x tends to a plus, this is a minus, which is equal to f of a. So then f of x is continuous. So definition both are same. Okay, the function f of x is said to be continuous. It satisfies this condition. So that is f of x is defined at x is equal to a, and f of x is exists at x is equal to a, and the value limit, left hand limit is equal to right hand limit, and is equal to value of the function. Then the function is said to be continuous. Next. So any of the condition is not satisfied. Suppose the function is said to be discontinuous. The function is said to be discontinuous. Okay. So if discontinuous function, discontinuous function. Okay. So first one is if f of x is not defined, f of x is not defined at x is equal to a. Okay, so f of x is not exist at x is equal to a. And so third one is so limit of f of x tends to a minus, which is not equal to limit of f of x as x tends to a plus, which is not equal to f of a. See here, so any one of the condition is not satisfied. So whether the function is not defined at x is equal to a. So any one of them. Okay, so not all these. So if any one of the condition is not satisfied, so then the given function is said to be a discontinuous function. Say suppose f of x is not defined at x is equal to a. So then also it is discontinuous. F of x is not exist. F of x, suppose it is not exist at x is equal to a. So then also it is discontinuous. Limit of f of x is not equal to limit of f of x as x tends to a plus. That means LHL is not equal to RHL. So then it is also discontinuous. Or suppose both LHL and RHL exist, but that is not equal to value of the function. So then also it is not continuous. Okay, so write down. Okay, so next. So take the general meaning. That is note, intuitively, a function is continuous in its domain if its graph is a curve without breaks or jumps through its domain. domain. Okay, so and one more word. So a function is continuous. The function is continuous at a point in its domain if its graph does not have breaks or jumps in the immediate neighborhood of the point. Okay, so this is the general meaning of continuous functions. Intuitively, a function is continuous in its domain if its graph is a curve, without break or jumps through its domain. So the given domain, so it has no breaks and jumps. Okay, so a function is continuous at a point, so particularly at a point in its domain if its graph does not have breaks or jumps in the immediate neighborhood. So that is, immediate neighborhood is nothing. Suppose here there is a graph. Okay, so suppose at x is equal to a. So this is from the left side. So limit f of x as x tends to a minus. Okay, so this is limit f of x as x tends to a minus. The function move from right to the approaches to a. So and the value of f of x is also same. So that is the neighborhood. Okay, so immediate neighborhood a plus. So a plus is neighborhood point of a, and a minus is neighborhood point on the negative side, and a plus is the neighborhood point on the positive side itself. Okay, so a minus is nothing but it is not a negative number, and a plus is not a positive number. Just it is a point left to a and point right to a. Okay, so that is the immediate neighborhood point of a. Okay, so right now. Another method is also there. So limit of the function is exist if left hand limit is equal to right hand limit. Okay, already you know that. So a function f of x. So note. Okay, a function f of x is said to continuous at x is equal to a if so limit of f of x as x tends to a, so which is equal to f of a. So this is also same meaning. So same meaning. So left hand limit is equal to right hand limit is equal to value of the function. Okay, sometimes we are just finding the limit of the function and value of the function. If the limit of the function and value of the functions both are same, so then also the given function is continuous. Okay, so in the generally trigonometric functions are continuous. Okay, so already know that not all the trigonometric functions. So the sin x and cos x are continuous everywhere. So see it. So graph of sin x. So this is just real number. Okay, so this is 0, 90, 180, 270, and this is 360. So minus 90, minus 180, minus 270, minus 360. So sin 0 is equal to 0. Okay, so 1 is again 0, 270 minus 1, and again this is 0. So 90, 270, 360. 90 is the dividend, minus 1. So again, see here the graph of so like this. So this is the graph of sin x. F of x is equal to sin x. Okay. So it continues. So for all real numbers, so okay, it is continuous at every way. Okay. Similarly, cos x is also continuous at every way. So but tan x and secant x and cosecant x are continuous in its domain. Okay. So particularly, so tan x and cot x are discontinuous. Okay. So tan x, for example, f of x is equal to tan x. F of x is equal to tan x is discontinuous at odd multiple of pi by 2. Okay, so 2n plus 1 pi by 2. Okay, so this is discontinuous. So therefore, particularly tan, secant, cosecant are continuous in its domain. So take it as the points. Remember. So points to be remembered. Points to remember. So first one is so polynomial function are continuous every way. Okay, so every polynomial function, any polynomial function is continuous every way. Okay, so next one is sin x, cos x, and mod x are continuous every way. Yes, sin x and cos x and mod x are also continuous every way. And third one is so tan x, cot x, cosecant x, and secant x are continuous in its domain. Okay, so and log x is continuous in the interval 0, infinity. Okay, so these are the points to be remembered. Okay, so every polynomial function, this is the form already ordered. First we see, so f of x is equal to a naught plus a1x plus a2 x square plus and so on plus an x to the power of n. So this is the polynomial functions. So that means every polynomial function is continuous every way. Okay, so sin x and cos x are continuous every way. Okay, so that any real numbers that is continuous, there is no break or there is no jumps in the graph of the curve. Similarly, mod x is also modulus functions. F of x is equal to mod x. It is also continuous every way. Okay, for any real number, the mod x is continuous. So similarly, tan x and cot x and cosecant secant x are continuous in its domain. Okay, that means so in particular point, tan x and cosecant x are cot x are discontinuous. Therefore, particularly we are so taken in its domain only. Okay, so log x is continuous in the interval 0 to infinity. Okay, right down. continuous function. Okay. So let f and g are two continuous functions. So I am taking f and g are two continuous functions and so k be any constant. Okay. So then the first one is f plus g is continuous. F plus g is continuous, and second one is f minus g is continuous. Okay, at x is equal to a. Okay, particularly at x is equal to a, at x is equal to given point, at x is equal to a, and here also f of x and g of x are two continuous functions at x is equal to a, at x is equal to a. I am taking here the function f and g are continuous at x is equal to a. So then the sum of two continuous functions is also continuous. So that is f plus g is continuous at a particular point, that is x is equal to a, and difference of two continuous functions are also continuous, that is f minus g is also continuous, and k into f is continuous at x is equal to a. So that is the scalar multiplication of a function. So scalar is a constant, k into f is also continuous. If it is continuous, then k into f is also continuous at x is equal to a. And fourth one is f by g is continuous. f by is continuous at x is equal to a, provided so g of x is not equal to 0 in the denominator. So that is g of x is not equal to 0. So then the quotient, that is f of x and g of x, is also continuous at x is equal to a. Third one. So next we move on to problems. The first one is, so examine whether the function, examine whether the function f of x is equal to x square minus 9 divided by x minus 3 continuous at x is equal to 3. So we are going to examine whether the function is continuous at x is equal to 3 or not. Okay. So observe. So you already know that the definition of continuous function is limit of the function f of x is defined at x is equal to a, and second condition what, f of x is exist at x is equal to a. Okay, so but here we are going to verify whether the function f of x is defined at x is equal to 3 or not. Okay, so solution at x is equal to 3. So f of x become, so f of x is equal to x square minus 3 divided by x minus 3 become. So there x is equal to 3, f of 3 is equal to 3 square minus 9 divided by 3 minus 3. It is f of 3 is equal to, so 0 by 0. So f of x is not defined at x is equal to 3. So therefore, so this is not continuous. Therefore, f of x is not continuous. Is not continuous at x is equal to 3. Okay, so particularly the function f of x is not continuous at x is equal to 3. At the particular point, so this is not continuous. That means, so at the particular point x is equal to 3, there is a break or there is a jump in the graph of the curve. Next problem. So given f of x is equal to x cube minus 8 divided by x minus 2. So for x is not equal to 2, okay, and f of 2 is equal to 12. F of 2 is equal to 12. Check whether the function is continuous at x is equal to 2. Okay, so see here, solution. In the given problem, f of x is equal to x cube minus 8 divided by x minus 2. So by data itself, x is not equal to 2. Okay, so for x is not equal to 2, for x is not equal to 2, f of x is equal to x cube minus 8 divided by x minus 2 is defined. Okay, so if you put x is equal to 2, then it is not defined. So because 2 cube minus 8, again 2 minus 2, we get 0 by 0. That means it is not defined. So therefore, what x is not equal to 2, this is defined. And one more thing is given, and f of 2 is equal to 12 is given. So by data, so we need to find the limit of the function and the value of the function. So value of the function is already given. F of 2 is equal to 12 is given. So therefore, we need to check the limit of the function. So we know that limit f of x as x tends to a. We need to find the limit of the function. That is limit of f of x as x tends to a. So that is limit of, so f of x as x tends to 2 plus 2. Okay. So which is equal to limit of f of x is equal to x cube minus 8 divided by x minus 2 as x tends to 2. So here at x is equal to 2, this is not defined. So therefore, so this can also be written as, okay. So that is which is equal to limit of x cube minus 2 cube divided by x minus 2. Okay, as x tends to 2. Okay. So again, so we expand this using the formula. So expand it a cube minus b cube formula. Okay. So because at x is equal to 2, this is not defined. Therefore, we are going to vanish x minus 2 and the numerator also x minus 2. So simplified. or take another formula otherwise. So x to the power of, there is a formula. So limit of f of x as x tends to a, that is limit of NA, limit of x to the power of n minus a to the power of n divided by x minus a as x tends to a is equal to NA to the power of n minus 1. So there is a formula in the first VC. So by using that formula, the limit of x to the power of n minus a to the power x minus n minus a to the power of n divided by x minus a is equal to NA to the power of n minus 1. So by using that formula also we can evaluate this. So which is equal to CA, because here x is x and in place of a 2 is there and in place of n 3 is there. So therefore n, that is 3 into a, that is 2 into, okay, n minus 1, that is 3 minus 1. So which is equal to 3 into 2 to the power of 2 to the power of 4, that is 3 into 4, which is equal to 12. So that means limit of f of x as x tends to 2 is 12. That is limit of f of x as x tends to 2 is 12. Okay. So here f of 2 is 12. Okay. So therefore the limit of f of x as x tends to 2, which is equal to f of 2, which is equal to 12. So therefore f of x is continuous. The given function is continuous. So because so limit of the function is equal to value of the function. So therefore the given function f of x is continuous. Okay, right now? Okay. So in the next sessions we are going to discuss some more problems. Thank you.